right, guys, welcome into our first real section. Now that we have kind of gotten our review out of the way, we're going to be going over 1.1, which is greatest common factor. And so for think slash 1.5, remember when we started distributing and we talked about how 7 times 13 is the same thing as 7 times 10 plus 3, which would get us, when we factored out 7 times 10 is 70, and 7 times 3 is 21. Now we're kind of going to go the other way, right? And so just think about it. Don't you agree that if I had 70 plus 21, do you see how I could kind of like take out a 7 or divide both by 7? And then I could go back to 7 times 10 plus 3, because 7 times 10 is 70, and 7 times 3 is 21. So now we just kind of have to think backwards, right? And we'll get into an example, and that'll be a little more clear. So factors, what is a factor? Factors are two numbers that you can multiply to get another number. So examples 3 and 4 are factors of 12, since 3 times 4 equals 12. And 1 and 12 are also factors of 12, since 1 times 12 equals 12, right? Two numbers multiplied together to get another are factors. And another way to think of a factor is anything that is divisible, evenly divisible. So since 12 divided by 4 is 3, right? Then 4 and 3 are also factors, right? So you can think about it that way. And now we need to get used to factors when we have variables involved, right? So for example, 2x and 3x squared are factors of 6x cubed, since 2x times 3x squared is 6x cubed, right? Technically, all the factors is, we can do 2 times 3 times, and then x cubed is x times x times x. Those are all the factors of 6x cubed, and then we could have 1 times 6 as well. But yeah, so the greatest common factor, which we're going to focus on today, is the set of a set of numbers. So of like a few numbers is the largest factor that all the numbers share. And I think once you talk about an example, that'll become more clear. So the greatest common factor of 5 and 15 is 5, because that's the largest thing that divides both of them, right? 5 divided by 5, you can do that, and 15 divided by 5, you can do that. But you can't go any higher, right? As soon as you go higher than 5, 6, you can't divide 5 by 6 nicely. So another example, the greatest common factor of 15 and 21 is 3, since it's the largest factor of both 15 and 21, right? You can't divide both of those by 5, but you can certainly divide both of them by 3, right? 15 divided by 3 is 5, and 21 divided by 3 is 7. And just like before in the previous slide, expressions with variables can also have a greatest common factor. So the greatest common factor of 15 x to the 4th and 21 x to the 5th is 3x to the 4th. Now I kind of combined this, right? I used this 15 and 21 from up here. The greatest thing that divides both 15 and 21 is 3, so we have that 3. And then notice we have 4 x's here and 5 there, so the most that they share in common is 4. So I could take out an x to the 4th. That's what they have in common, right? The greatest common factor. And we'll get into a few examples. And before we do, we're just going to kind of recall distributing to warm us up. So distributing is multiplying, right? And if we do 3x times 2x squared, 3 times 2 is 6. X is x to the first. X to the first times x squared is x to the third. 3x times 1x is going to be 3x squared. And 3x times negative 6 is going to be 3 times negative 6 is negative 18. And then we have that x out front. And looking at this one, same thing. Negative 5x squared times 4x to the 4th. Negative 5 times positive 4 is going to be negative 20. And then we have 2x's times 4x's, which will leave us with 6x's multiplied together. Then negative 5x squared times negative 3x squared. Negative times a negative is a positive. 5 times 3 is 15. And x squared times x squared is x to the 4th. And then negative 5x squared times positive 1, we're going to get minus 5 x squared, right? That x squared just hangs out front. And this is something we should already know how to do, but now we're going to be going backwards, right? So in future examples, we're going to have to go from this to this. And that's what we're going to get into. So factor out or factor each expression completely. So what I'm asking is, what is the biggest thing that can go into both 42 and 30? And maybe I don't know it off the top of my head, but I am looking at that and I'm like, well, I know 2 comes out of both of them, right? So let's take out a 2. And then do we have any x's? Well, this one has x's the first term, but the second term doesn't have any x's. So let's just do that first. And then I'm asking 2 times what is 42x squared? Or you can do 42x squared divided by 2. And the answer to that is going to be 21x squared, right? Because if we were to multiply 2 times 21, we'd get 42, and then that x squared out front. And then here, plus 30, 2 times what is going to get us 30, and that's 15. Oh, I noticed that this something can happen even more, right? So what can I pull out of 21 and 15? We did this earlier, right? We could pull out a 3. And keep in mind, we're multiplying here. So then 3 times what is 21x squared? And that'll be 7x squared. And then 3 times what is 15? And that'll be 5. And then we can do the 2 times 3 out front, which is 6 times 7x squared plus 5. And we could have jumped straight to the 6, right? But I was just kind of demonstrating that maybe you can't think of the number right away that can come out of it. But and then to test it out, 6 times 7x squared, 6 times 7 is going to be 42. And then x squared is up front. And then 6 times positive 5 is 30. So that checks out. Now, this one's a little weird because looking at the numbers, I don't see anything that can come out of 3 and 1, right? We have an invisible 1 in front of that x. But now I'm looking at the variables, and they both share an x. So I can take out an x, and then what I'll be left with is x times what is 3x cubed, and that'll be 3x squared. And then x times what is x. And this is a weird one, and this one's important. But we need a plus 1 there, right? Because if we were to multiply this back out, we would need x times 3x squared, which is 3x cubed, and then x times positive 1, which gets us that plus x. So we need that plus 1 there for it to be correct. And that'll be our answer. And then down here, same concept. I'm looking at the numbers first, 4 and 16, and I'm just going to recognize that, I could take a 4 out of both of those. And now I'm looking for variables. The one on the left has an x, but the one on the right doesn't have anything, so I can't take out any variables. So 4 times what is 4x, and that'll be x. And then 4 times what is negative 16, and that'll be negative 4, right? That negative is important, so that'll be our final answer for that one. Moving on. Here we're looking at similar things again. So first thing, I'm looking at the numbers. What can I take out of both 30 and 36? And if you can't think of it right away, just do it in steps like I did the first one. Take out 2 first, and then here we go. Take out 3 first. But I noticed that I can take 6 out of both of these. So I'm going to take 6 out. And now I'm looking at the variables. How many variables do they each share? Well, this one has 3 x's, and this one has 5 of them. So the most that they share is x to the third, right? So we can take out x to the third. And then when we multiply, I'm asking 6x cubed times what gets me 30x cubed? Well, we already have the x cubed, so we really only need the 5, right? Because 6x cubed times 5 is going to get us the 30x cubed. So we don't need any x's there. And now we have a plus. And then 6 times what is 36? That'll be 6. And then x cubed times what gets us x to the 5th, and that'll be x squared is what we need there. And that'll be our final one. And again, it might be shaky at first, but just think about multiplying it back out, right? 6x cubed times 5 is going to give us 6 times 5 is 30, x cubed just hangs out front. And then 6x cubed times 6x squared, 6 times 6 is 36. X to the third times x squared is x to the fifth. And so we see that we'll get the same thing. And so that's checking our answer to make sure it is correct. But our answer is this, right? So same thing here, except now we have two negatives. And I'm just going to show you something. When I see two negatives or a leading negative, I like to factor out a negative, right? So I'm thinking the biggest thing that can come out of 30 and 50 is 10. But just to be nice, I want to get rid of those negatives. So I'm going to factor out a negative 10. And then I'm looking at the variables now, x to the fourth, x squared. The most that they share is the x squared, right? And now we're going to rewrite this squared here. Squared. And now negative 10x squared times what is 30, negative 30 x to the fourth. Since I took out that negative, it's now going to be positive, right? And that'll be 3, and then we have x squared, and we need to get x to the fourth, so we're going to do another x squared. And then same thing here, since I took out a negative, it's now going to be positive. 10 times what gets us 50, and that'll be 5, and then x squared, we already have that x squared, so it's just going to be left like that. And it's plus now in here because I took out this negative out front. You don't have to take out the negative, right? You could also just take out a 10x squared, and then you'd be left with negative 3x squared minus 5. Those two are the same things. However you want to do it, I just like to take out a negative if I have to. And now this one might look weird, but don't freak out. I think this one might actually be easier than the others in a way, because we don't even have to worry about the numbers, right? So there's no numbers, so I'm going straight to the variables. What's the most amount of x's each one of these share? This one has 2, this one has 5. So the most amount they share is x squared. And now what's the most amount of y's they share? Y cubed, right? That one is 3, that one is 4. And now we make our parentheses. X squared times y cubed times what gives us x squared y cubed? That's just 1, right? That's another one of those tricky ones. We need that 1 there. And then we have a minus sign. And then we have 2 x's and we need to get to 5, so we better have x cubed. And we have 3 y's and we need to get to 4, so we better have 1 more y. And that'll be our answer for that one. So that is factoring out a greatest common factor.